So today we're going to start talking about multiplying with monomials and polynomials. And so when we have a monomial, we're multiplying it by a polynomial, we just make sure that we distribute that monomial to all of the terms in that polynomial. What we need to remember is the product rule from our exponents that we've discussed in the past. So remember that when you have a variable with an exponent and you're multiplying it by another, you're going to add those exponents. Okay, so product rule says that when we're multiplying monomials or multiplying polynomials, terms together, we're going to add exponents. So for example, a couple of examples here, we're going to be multiplying, we're going to distribute this x to both terms in this binomial here. So x times x becomes x squared, x times 4 becomes 4x. Then we check to make sure we don't need to simplify any further. But here we have an x squared and a 4x, and they are not like terms, so we can leave our answer just like this. Also make sure that it's in standard form, and in this case we do have highest exponent first, so it is in standard form. Okay, then example like this, we're going to do the same process, but we're going to distribute this 5m cubed to all three of these terms. So 5m cubed times 3m squared becomes 15m to the 5th power. Okay, if you need to, go back and kind of review our notes on multiplying monomials together if you're struggling with this multiplication piece. 5m cubed times negative m becomes negative 5m to the 4th power, and 5m cubed times negative 7 becomes negative 35m cubed. Again, I'm already in standard form. All of these are unlike terms, so I can't combine them, and so we end up with this as our final answer. Okay, so just a couple of little things that may pop up, a couple of little examples. Don't forget that when we start adding in some additional variables, like for example number 9 here, I've got more than one variable, so I'm going to take this p squared q cubed and I'm going to multiply it by these two terms. So p squared q cubed times p to the 5th power q squared becomes p to the 7th power q to the 5th power, and that times the negative p cubed becomes negative p cubed q to the 4th power. And again, these are not like terms, so I can't combine them any further. We're going to leave our answer just like that. I'm sorry, that's just a little bit blurry. Hopefully the camera will readjust here in just a second. Hopefully. Okay. Then, we also have the, well, what if I have some variables there but not in other terms? And again, we would treat that just the same. So if you want to look at number 12, this would be another example. We could do 3ab times 4a squared becomes 12a cubed b, and then 3ab times negative 7b cubed becomes negative 21ab to the 4th power. And again, check to make sure that it's in standard form. A comes first, highest exponent first, and then bring it down. These are not like terms, so I can't combine them, so we can leave our answer just like that. So these are really good types of questions. So use the remaining questions up here just to check your understanding. Make sure you don't have any questions. If you do, please by all means ask them. But this is all just kind of a review of what we've done with multiplying monomials before. We're just adding in additional steps, adding in a couple more terms that we're multiplying at the same time. So we do have a few mixed operation questions here where we have a few additional pieces of to work with. So just don't forget your order of operations. Here we have multiplication and then we have addition. So I'm going to multiply first. Negative 2x times 3x becomes negative 6x squared. Negative 2x times negative 4 becomes a positive 8x. And then we have this addition down here. So now we can combine any like terms if we need to. And it just so happens that these are like terms, so I can add those together. Remember, when I add them, I am not adding the variables or the exponents, just the coefficient. So I want to leave my final answer like this, and just double check that your answer is in standard form. And it is in this case, so we're okay. All right. Now, if it does get a little bit more lengthy, like for example number 21, this one has a lot of pieces to it, but just take it step by step, slowly. I'm sorry, that will refocus hopefully here in just a second. There we go. So we're going to multiply first, and I have these monomial to distribute to several polynomials here. So I have a little bit of work to do here. So first off, I'm going to multiply 3b times 7b, which becomes 21b squared, and 3b times negative 2 is negative 6b. Then we have this positive 3 being multiplied by y squared, which is v squared, 3v squared. 3 times 2v is 6v, and then 3 times 1 is is 3. Then I have this negative 3v squared that I'm multiplying by negative 5v, which is positive 15v squared, and negative 3v times 3, which is negative 9v. Okay? So now I can clean this up and simplify any like terms that I have. And in this case, I do have 3 terms that are all v squared, so I can add those. I have 21 and 3 and 15, which becomes 39 v squared. And again, I'm not changing exponents and variables when I'm adding and subtracting, only when I'm using that multiplication or product rule. Then I have these 3 with our v's. I have a negative 6v and a positive 6v, which zero out, and I have a negative 9v, which is negative 9v plus 3. Okay, so continue your understanding there, or checking your understanding. Same thing with the geometric applications. We've done practice like this. Give them a shot, and if you have any questions, you can let me know.